All right, guys, today we're talking about classifying quadrilaterals, and our objective is I can name the different kinds of quadrilaterals and understand how a polygon can be more than one kind of quadrilateral at a time. For example, a square is also considered a rectangle. Okay, so we're going to be using a little flow chart to help us figure out those kind of problems. So let's get some vocabulary out of the way first. A quadrilateral is just a four-sided polygon. Quad is the root, that means four. Okay, just like a pentagon is a five-sided figure and a hexagon is a six-sided figure, a quadrilateral is a four-sided polygon. So then that means, okay, well, what's a polygon? A polygon is just a closed figure with no curves. So a circle, not a polygon. A heart, not a polygon. A shape like this, not a polygon because it's not closed. However, if we were to close it, then that would be a polygon. Parallelogram. A parallelogram is a quadrilateral with two sets of parallel lines. You have one set here and another there, and that is your classic parallelogram with one set of parallel lines and another set here. And I want you to draw these shapes with the markings so you can start to get used to what these markings look like. Our next one is a rectangle. A rectangle is a parallelogram with four right angles. So I think you guys are pretty familiar with a rectangle, but some ways that you might not have thought about it before is, yeah, a rectangle has four 90-degree angles. I'm sure you guys knew that. But it also has two sets of parallel sides. And remember, a parallelogram, from our last definition, is any quadrilateral with two sets of parallel lines. So a rectangle is also a parallelogram. It has two names. A rhombus is our third kind of quadrilateral we're going to talk about, and it's a parallelogram once again, but it has four equal sides. So, let's see if I can pull this off. Oh, it's not the perfect rhombus, but we're going to use markings that tell us each of these sides is equal. They're congruent, okay? And also the lines, the opposite lines, are parallel. Okay, so these are the markings for a rhombus. You'll be seeing them a lot. And then we have a square, which is a parallelogram that has four equal sides and four right angles. So it has the characteristics of a rectangle and a rhombus put together. And you guys know what a square looks like. Lovely square, but we're going to put the markings in. We've got right angles here. We have four congruent sides. And we have two sets of parallel lines, which I'm running out of room for, aren't I? Okay, so those are some of our first basic quadrilaterals, and we're going to use a flow chart to kind of make sense of all of these different things. So on the back of your notes, there is a chart that looks just like this, and the very top box, you're going to have to turn your page to the side. The top box is quadrilaterals, and the four quadrilaterals we learned about, parallelograms, rectangles, rhombuses, and squares, go in this section right here. So directly under quadrilaterals, I want you to put parallelogram. And on this line right here, I want you to write two sets of parallel lines. If something's going to be in this section of the chart, it has to have two sets of parallel lines. Now, if we put a little rectangle in here, a rectangle has two sets of parallel lines and four right angles. So that's what should go on this line, four right angles. A rhombus has two sets of parallel lines and four congruent sides, or four equal sides. And then you can see here that the square is just a combination of a rectangle and a rhombus. It has two sets of parallel lines, four right angles, and four congruent sides. And that is what gives us a square. All right, moving on. we're going to talk about three more parallelograms that are going to end up living in our chart. And the first is a trapezoid. A trapezoid is a quadrilateral with exactly one set of parallel lines. So you're most familiar with trapezoids that look something like this. All right. And these, what's frequently drawn as the bottom line and the top line are parallel. Those are actually called base 1 and base 2. All right, the two parallel lines. But don't get confused, because you can also have a trapezoid drawn like this, kind of tilted on its side. And then the parallel lines are over here. You just have to look at which two lines are never going to meet if they continue on forever and ever and ever. An isosceles trapezoid is very similar. It's a trapezoid with one set of parallel lines, but the slanted sides are congruent. So I'm going to use some of my shapes up here. Hang on, let me find the right one. To draw an isosceles trapezoid. And you can see that this line and this line are the same size, they're congruent, and that it is one set of parallel lines exactly. And finally, the last quadrilateral we're going to talk about is a kite. And a kite, let's go fly a kite, is a quadrilateral with no parallel lines whatsoever. So it might look something like this. None of those lines are parallel to each other, although that last one kind of does look like it. I'll fix it. There you go. None of those lines are parallel, none of those lines are congruent, but it is definitely a quadrilateral because it has four sides. All right, so that's what a kite is. Let's go back to our chart and plug these words into this quadrilateral chart that we have. So over here, we're going to have trapezoid. And remember, a trapezoid is a quadrilateral that has exactly one set of parallel lines. And then we have down below isosceles trapezoid. I-S-O-S-C-E-L-E-S. You guys are never going to forget that now, are you? And an isosceles trapezoid has two congruent sides, okay? And finally, the last word for our chart is a kite, and a kite has no parallel sides. Make sure you have all these extra little notes written in here. Those are really super important, and I will be looking for those tomorrow. And there's one really neat thing we can do with this chart that we've made here. And let me show you what that is. So I'm going to write up at the top, I'm going to write the word sum. And at the bottom, I'm going to write all. And the way we can use this chart is that if we are moving down the chart, some quadrilaterals are parallelograms. Some parallelograms are rectangles. Some trapezoids are isosceles trapezoids. So anytime we're moving down the chart, we can use the word sum to describe the relationship. Some rectangles are also squares. When we go up the chart, it works a little bit differently. So when we move up, go from, say, square to rhombus, we can say all squares are also rhombuses. And we can look at isosceles trapezoids. All isosceles trapezoids are also trapezoids. One last thing we can do with this chart is talk about moving left to right, okay? And we're going to use the word never. Kites are never trapezoids. And you can see how that would make sense. A kite has no parallel sides, and a trapezoid has one set of parallel lines. So a kite can never be a trapezoid. A rhombus is never an isosceles trapezoid. A rhombus is never a trapezoid. Okay? So we can use these some going down, all going up, and never going left to right to really help us understand how these quadrilaterals work together and are related to each other. Keep in mind that any one quadrilateral can have many, many names. If I take a square, for example, this square here has four congruent sides. It has, four congruent sides, four 90-degree angles. It has two sets of parallel lines. So this square can be represented as a square, a rhombus because it has four congruent sides, a rectangle because it has four right angles, a parallelogram because it has two sets of parallel lines, and finally a quadrilateral. So this square actually has 5 different names that it can be given that are all accurate. If I was asking for the most specific name, it would be considered just a square. All right, guys, my gift to you is no reflection tonight, but when you come in tomorrow, I better see these notes completed. Thanks. Have a good one. Bye-bye.